Okay, we're gonna work on lesson 11. This starts on page 44, which talks about powers of 10. So the words you need to know for this lesson are exponent and power. In the base 10 number system, powers of 10 are written as the number 10 with an exponent. An exponent shows how many times 10 is used as a factor, or how many times 10 is multiplied by itself. So right here, if you have 10 with an exponent of 3, we call this 10 to the third power, or 10 to the power of 3. And that 3 is the exponent, and it tells me how many times I'm going to multiply 10 by itself. It does not mean I'm multiplying 10 times 3. It means I'm multiplying 10 by itself 3 times. So I'm taking 10 times 10 times 10, which is also equivalent to 1,000. So here's kind of a cool pattern that you can figure out what your powers of 10 are by counting zeros. So let's start over here on the right, the exponent form. So 10 to the first power is just 10, just 1 10. It's not 10. You can also say it's like 10 times 1, which equals just 110. 110. So 10 to the second power, or 10 squared, would be 10 times 10. Now, if you notice, this number is 2. How many 10s do you have? 2. How many zeros are in 2 10s? 2. What's the final answer? 100. How many zeros are in 100? 2. So then 10 to the third power, or 10 to the power of 3, has 3 10s. 10 times 10 times 10. How many zeros are there in 3 10s? 1, 2, 3. And then the final answer would be 1,000. How many zeros are in 1,000? 1, 2, 3. And then 10 to the fourth power, or 10 to the power of 4, has 4 10s. 10 times 10 times 10 times 10, which equals 1,000. Well, there's 4 zeros in 4 10s. There's 4 zeros in 10,000. And then 10 to the fifth power, or 10 to the power of 5, has 5 10s. 5 times 5 times 5 times 5 times 5. And the final answer would be 100,000, which also has 5 zeros in it. So that's kind of how you can use your patterns, or simply figure out your answer, is by looking at the number of 10s, or looking at the exponent, and whatever that number is how many zeros you're going to have in your final answer. So the write-up down here says you can use the pattern in powers of 10 to mentally multiply whole numbers. To multiply a number by a power of 10, write zeros at the end of that number. So our example, so what we can use powers of 10 when we write a scientific method or scientific notation. That just means we're writing like a smaller version of the number by simplifying that number by using the powers of 10. So we can use our powers of 10 to multiply by whole numbers. So we're going to use mental math to decide how many zeros to place after the whole number. So your base here is basically 10 times, or 18 times 1. What is 18 times 1? It's 18. But this is 10 to the fourth power. So 10 to the fourth power, if you look up here, is 10,000, and it has 4 zeros in it. So your answer is going to have 4 zeros behind the base number here. So since 18 times 1 is 18, but it's 10 to the fourth power, you have 4 zeros behind 18, or you place those 4 zeros back there. So our discussion is, how can you use patterns of zeros to find the product of 40 times 10 to the third power? So basically, what is 40 times 1? It's 40. So our base number is 40. So it has that 0 already in it because that's our base. And then 10 to the third power up here is 1,000. So really what you're doing is you take your 40, your base number, and you place 3 zeros behind it. So your final answer is 40,000. Now that's tricky because you might think, well, if it's 40 times 10 to the third power, then you would just need 3 zeros in your answer, correct? Well, that's not necessarily true because your base already has a 0 in it. So if you just had 4 and then placed 4 or 3 zeros behind it, that is not the correct answer because you need a total of 4 zeros behind the 4 because this one of the zeros is already in the 40. All right, let's take a look at what else we're going to learn in powers of 10. What is the value of 10 to the 6th power? Determine how many tens is used as a factor. In 10 to the 6th power, the exponent is 6. 10 is used as a factor 6 times. Apply the pattern with powers of 10. The base numeral for 10 to the 6th power has 6 zeros. So the value of 10 to the 6th power, so you have your 1, right? And then you're going to place 6 zeros behind it. 1, 2, 3, 4, 5, 6, which is 1 million. Now, you could say, oh, well, I already have my 10 there. Well, your 10 is your power of 10, so you're still counting that 0 right there is one of the 6 that you're talking about. So you need a total of 6 zeros there. All right, so find the product of 684 times 10 to the power of 5. So decide how many zeros to place after 684. In 10 to the power of 5, the exponent is 5. So write 5 zeros. Use mental math to multiply. Well, 684 times 1 equals 684. So my base number, or my numerals that I'm going to place in my number is 684. Then I have to put 5 zeros behind that. And then I count back to place my commas. So my final answer is 68,400,000. All right, let's keep going. How can you use mental math and what you know about powers of 10 to multiply 92,000 by 10 to the power of 3? So my base, I already have 92,000. So I'm just going to write those numbers out without the commas. 92 and then 1, 2, 3. And then I'm going to multiply that by 10 to the 3rd power, which is 1, 2, 3. And so my final answer is going to be this number right here, my first factor, with 3 more zeros at the end. So I already have 1, 2, 3. Now I'm going to place 1, 2, 3 more zeros at the end. So now I have 92 million. A number has a 5 in the thousands place. You multiply the number by 10. Where will the 5 in the product be? Explain. So if a number has a 5 in the thousands place, let's say we have n, and then we have our 5 in the thousands place, and then we have n, n, n. So if we multiply this number times 10, that 5 is going to go up 1 place value, isn't it? So it's going to be in the 10,000s place because it goes up 1 place value. Okay, complete the table to show the patterns in multiplying powers of 10. So we've got 9 times 10, which is also equivalent to 9 times 10 to the 1st power. And then the product is 90. So now we've got 9 times 10 times 10, which is also equivalent to 9 times 10 to the 2nd power, or 900. So I assume our next one is going to be 9 times 10 times 10, which is also equivalent to 9 times 10 to the 3rd power, which is also equivalent to 9 with 3 zeros behind it. And then our next pattern is going to be 9 times 10 times 10 times 10 times 10, which is also equivalent to 9 times 10 to the 4th power, which is 9 with 4 zeros behind it, or 90,000. So you're going to go ahead and do the rest of these. Basically, we've got some that have our actual powers of 10, or the numbers using exponent, and then some that are just the powers of 10 already written out. So you just use your base. 35 times 1 is 35, and then you place however many zeros are behind it. behind each factor. So like this one down here, you have 2 here and 2 here. So my numerals are 69 with 4 zeros behind it. So 690,000. And then this one right here, we'll skip all the way over to here. We already have 15,000 as our number, right? And then we're gonna multiply it by 10 to the third power. So I'm placing 3 more zeros at the end of that number. So I get 15 million. So go ahead and do the rest of these on your own. And when we meet on Zoom next week, we'll go over your answers to see how you did. I'm gonna keep going to the next lesson. If you wanna pause this and go ahead and do that work, you can do that, or you can just keep going with me and then go back and do the work later. So now we're gonna be multiplying and dividing with powers of 10. So when we multiplied by a power of 10, we made the number bigger. So when you divide by a power of 10, you're actually going to be making the number smaller. You're actually going to be really multiplying it by a fraction or dividing it by 10. So let's take a look at some of these. It says when multiplying a decimal by a power of 10, use the exponent to decide how many places to move the decimal point to the right. So you're moving the decimal point to the right in order to make the number bigger. So an example of that, if I had 4.2 times, actually let's do 4.22 times 10 to the second power. So this is 10 to the second power. So I'm gonna multiply it really by 100, but this is a decimal. So if I did this, and place 2 more zeros at the end, it does not change the product at all. So what you have to do is you're actually moving this decimal however many places that power tells you, or that exponent tells you. So I'm gonna move that decimal over 2 times, and my answer is 422. So what if there wasn't a digit there? So what if it were 4.2 times 10 to the second power? Okay, so here's my 4.2. I move that decimal over 1 place and then another place, and then I place a 0 there in order to hold its place value. So your answer would be 420, like that. When dividing a decimal by a power of 10, you use the exponent to decide how many places to move the decimal point to the left. So when you're dividing by a power of 10, you're actually making the number smaller. So for example, if I had that 4.22 again, but I was going to divide by 10 to the power of 2, I'm actually going to move the decimal to the left because I need to make the number smaller. So there's 1 place, and then I move it another place, and then I place a 0 there in order to hold that place value. So this, I'm going to erase that and write it below it. So if I had that 4.22, I'd move that decimal place over 2 times, and I'd place my 0 there to hold that place value. And my new answer would be 422 10,000ths, like that. All right, so let's take a look at the examples they gave you. Find the product of 7.53 times 10 to the third power. Decide how many places to move the decimal point to the right. It's multiplying, so we're making the number bigger. So if I multiplied 7.53 times 10 to the first power, I would just move that decimal point over 1 place, and it would be 75.3. If I was going to multiply it by 10 to the second power, I would move it over 2 places, and it would be 753. And then if I multiply it by 10 to the third power, I'm going to move it over 1, 2, 3 places, and then I'd place a 0 there to hold its place value, and I'd get 7,530. All right, so let's move on to example 2 and find the quotient of 3.9 divided by 10 to the second power. Decide how many places to move the decimal point to the left. So because you're dividing, you're making the number smaller. So if I had 3.9 divided by 10 to the first power, I'm moving that decimal place over just 1 place, and I'd get 0.39. And then if I'm going to divide it by 10 to the second power, I'm going to move it over 2 places, and then I would need to put a 0 there to hold the 10th place. So I would have 0.039. All right, let's take a look at your discussion box. When multiplying or dividing a decimal by a power of 10, how do you decide how many places to move the decimal point? It's just what the exponent says, what the exponent is. That's how many places you move the decimal, depending on the exponent, or that small number written above the 10. All right, find the product of, excuse me, 0.849 times 10 to the fourth power. Decide how many places to move the decimal point to the right. In 10 to the fourth power, the exponent is 4. Move the decimal point 4 places to the right. Write the product. So I'm going to write the original product here, or maybe I'll write it here, or the original factor. I'm going to write it there, and then I'm going to draw my decimal or move my decimal 4 places. 1, 2, 3, and then I need to move it 1 more place and place a 0 there to hold its place value. So my new product is 8,490. All right, and then if we divide, same thing, decide how many places to move the decimal to the left. Not the same thing because you're moving the decimal to the left because you're making that number smaller now. So the exponent is 3, so we're going to move the decimal point 3 places to the left. So again, I'm going to rewrite the original factor, 12.5, and I'm going to move the decimal point 3 places to the left. Just so I can see where it goes, I have to place a 0 there where the tenths place is to hold its place value. Now my new answer is 0.0125. Right? 1, 2, 3, yes. So it's 125 10,000ths. All right, let's keep going. How can you use mental math and what you know about powers of 10 to multiply 58 and 7/10 by 10 to the third power? Well, you can use mental math because you know that 58.7 times 1 equals 58.7. But now we're going to move that decimal. How many places? 3 places. Move decimal 3 places to the right. So if I have my original factor is this, 58.7, and I'm going to go 1, 2, 3, and place 2 zeros there to hold its place value. So now my answer is 58,700. All right, next question. How can you use mental math and what you know about powers of 10 to divide 93.5 by 10 to the second power? Again, you know that 93.5 divided by 1 equals 93.5. So your numbers in your answer are still going to be 9, 3, and 5. But because you're dividing, you're going to move the decimal to the left. How many places? What's the exponent say? 2 places. So here's my original number, 93.5, and I'm going to move it 2 places to the left. So my new answer is 0.935, or 935 thousandths. All right, so you're going to do these. They all look pretty simple. That if you followed along with what I just did, you should be able to do these pretty simply. I'll do the first couple with you. Number 3, it's multiplication, so you're going to go to the right. So if this is the original number, I'm going 1, 2 places, and my final answer is 610. Let's do this one together too. It's just times 110, so I'm just moving the decimal 1 place. So it's 47.9, and then this is division, and the excuse me, the exponent is 1. So I just move the decimal to the left 1 place value. So my answer is 0.97. And then same thing with this one. Here is the exponent, it is 3. You're dividing, so you're going to the left 1, 2, 3 places, and your new answer is 0.1007. All right, so you can do the rest of those on your own. They're pretty, if you followed along with that and you didn't have any trouble following along with this lesson part, this should be pretty simple. If you have any questions, you can Google chat me or email me and I'll help you with it. And then the last lesson that we're actually gonna do, two more really quickly, add and subtract decimals. I'm not gonna have you do all of the work in each one of these, just so you know how to do this and that you have to line up the decimals. You shouldn't have a big problem with it. When you add two numbers, the answer is the sum. You add decimals the same way you add whole numbers. Just remember to line up the decimal points, then place the decimal point in the sum. So this one's pretty self-explanatory. You have 1.86 plus 0.57. They have the exact same place values. They both have, well, there's a 0 in the units place, but you would line up the units place, line up the decimal plates, line up the tenths and the hundredths, and then just add normally. Just make sure you place a decimal point in the sum down here. So I'm gonna skip to this one over here really quickly. I'm gonna show you what you need to do when you don't have as many digits as you have place values. So when you have 2.62 plus 3.7, you notice this has 3 digits and this only has 2. So do you line them up like you would line up whole numbers with the smallest place values lined up? No, you don't. You have to make sure that the place values are all lined up. And the easiest way to do that is to line up the units place and the decimal, and then whatever you have behind the decimal. So in this case, this bottom number, I only have something in the tens place. Well, I can place a 0 there to hold that hundredths place in order to add it or even subtract it. So then I would just add those up, place my decimal point in my answer, and I would have a total of 6.32. All right, so your question is, explain how to find the sum of two decimals. You need to line up decimal and add. When adding decimals, when is it helpful to show an equivalent decimal? Just like we did on the one over here, 3.7 is equivalent to 3.70. So when is that helpful? When you need to place a 0 to hold its place value, when the other number has the same place value. So which ones would I like for you to do on here? These are all pretty simple. How about do the word problems, so 7 and 8. And then how about these are all pretty simple. How about you do 15, 16, 19, 18, and 20. So and 14. Those are the ones that you're gonna have to find some equivalent decimals to add. So for example, I'll do 14 with you. So if you have 32.9, so I'm just gonna rewrite them. I wanna go a little bit smaller so I can fit it. 39 or 32.9. And then I'm not gonna line them up like this, right? That's not correct. Even though they both have 3 digits in them, I have to make sure I line up the decimal. So this is 32 and that's 8. So I need to line up the 2 and the 8, line up the decimal point, and then put my 54. And then what do I need to put next to the 9? A 0 to hold that place value. Then I can simply add and get 41 and 44 hundredths. And then you can check those with a calculator if you'd like to make sure you have the right answer. So just make sure, that's like the easiest thing I can tell you about this is just line up your decimals and then place zeros where you need to hold the place value. And then the same goes with subtracting. This one is pretty self-explanatory, so take a look. I'm going to skip straight to page 57. And if you notice, we've got 8.5 minus 4 and 63 hundredths. So I'm going to write that vertically so I can subtract it. So I would not, so like normally when you would line up these numbers, you would put this number on top and this number below. Like if the decimals weren't there, you would do this, right? But that's not how you do it. You need to make sure you line up the decimals. So 8.5 is larger than 4 and 63 hundredths. So I got to line up the units and the decimals. So the 8 and the 4 get lined up, then the decimals, then my 63. And what do I put up here to hold this place value? A 0. Then I can subtract. This becomes a 10. This becomes a 4, 7. This becomes a 14. That's 8. Decimal point 3. So my final answer is 3.87. All right, so for this work, let's quickly answer these questions. Explain how to find the difference of two decimals. So you line up the decimal and subtract. And you need to make sure the larger decimal's on top, right? So why did you need to write an equivalent decimal when subtracting 8.5 and 4 and 63 hundredths? So when they say equivalent decimal, what you did is 8.5 is equivalent to 8.50. We wrote an equivalent decimal there because 4.63 has a digit in the hundredths place. So we needed something to subtract. Okay, so for this work, I'd love to see you do, I think the same ones actually. So 14, do 15, 17, 19, and 20. And then please, please, please do obviously the word problems too. Same with this one, make sure you do the word problems. Those are really important to do to make sure you know what you're subtracting. So for example, on this one, I will do this one with you. 13.76 minus 8.5. So I put the larger number on top. I line up the decimal. I place a 0 here to hold that place value, and then I subtract. And my final answer is 5 and 26 hundredths. And you can use a calculator to check that work. Or you could always add these two together, add the difference and the smaller of the numbers that you subtracted, and you should get the larger of the larger number. All right, so do these. If you have any questions, you can Google Google chat me or email me, and I'll help answer your questions. And we will do a Zoom next week. I'll let you know at the beginning of the week what day. Probably Tuesday. But I'll let you know. All right.